Namaste, dear students. Today we have this problem number 30 from the PSA paper. So here we are given small phi as the probability density of the standard normal distribution. Okay, and suppose we have f theta where theta is certain parameter and f theta is representing certain density functions. So as you can see, if theta is 0, then the observations are coming from the population which is standard normally distributed. And if the theta is 1, then that means we have this kind of a distribution, which is also normal, but it has sigma equal to 2, and this mean value is 1. So normal 1, comma 2. And we are also given a sample of size n, which are independent and identically distributed. Now we have to find out a sufficient statistic for theta. So these kind of problems are quite common. In also JAM exam, these kind of problems are asked, like where you have to find sufficient statistic, but the parameter takes maybe finitely many values. So one trick while solving this kind of problems is basically we have to incorporate the parameter, the information of the parameter with the density, right? And we have to find out the joint density or the joint likelihood and then use factorization theorem to find out the sufficient statistics. Now here, since we have just two possible cases, so we will use this indicator function where it is 1 if theta is 1 and it is 0 if the corresponding parameter theta is 0. Now this actually helps us to actually find out the density, and it can be expressed in a simpler manner in this form. So fx, where theta is the observed parameter or unknown parameter value, then the density is of this form. We are just taking the powers, and this is, very similar with the Bernoulli distribution, or you can say one of these two terms will remain, the other one will be just 1, will have just no contribution. So this will help us write down the joint density, which is nothing but the product of all the observations. Now after that we just have to simplify a little bit. So this small phi xi, this doesn't contain any information with the parameter. So we will take one part of that out, and then we will kind of divide this two because they have this I theta as the common exponent. And after simplification, we obtain this kind of a thing. And finally, we get this. So this is like g of tx theta, and this is like hx. So this part contains the parameter. This is free of parameter, just based on sample observations. And here it contains the parameter through the statistics summation xi square, summation xi. So out of the given options, definitely this tx vector, sum xi and sum xi square must be a sufficient statistic. So that is, I guess, option B. Yes, so option B is the correct answer. Okay, so that's all about this video. Thank you very much. Hare Krishna.